Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And what do people do, Cece, if they want to get a hold of us?
Thank you. Sorry, I
know, usually we have the kid here.
I was waiting for, I knew I was going to read that, but I was waiting for like another cue or something. So anyway, all right, yeah.
Oh, they gave you the buzz with that?
I know,
We're not even 20 seconds into the show.
That's sad. That's so sad.
All right, go ahead.
I'm sorry. Okay, for math homework help, call in Bakersfield 636-4357. Everywhere else, please dial 1-866-636-2684, or you can email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, well, thanks for doing that, Cece. Usually when we have a student, we talk about where they go to school, what grade they're in, and stuff like that. So. You have been with Do the Math. Mm-hmm. You were here the very first year.
I was.
And you have come back this year.
Yes.
So there was a little break in between there.
There was a little break.
So why don't you update some people and let them know where you are and kind of what you do now, other than coming in to do the math.
Okay, so I am at Bakersfield Christian High School, and I teach entrepreneurship and algebra there and enjoy the heck out of it. I have my son, who is the reason that I left. So for those kids that were definitely not watching 20 years ago, I had a kid, and he's in college now, so it's been a while.
A Badger, I do believe.
He is a Badger, University of Wisconsin in Madison. He's freezing his hind end off right now.
Well, that's good, because people in Kern County might be in a couple of days also. What is he studying, if you're able to share that with us?
Data science.
Okay.
So, yeah.
Which is a big thing now.
It is a very big thing when it talks about logistics and moving things around, all of the algorithms and stuff that go into that.
Because that is a very, very topic that is on top of everything else right now is data science.
Right. Although that's not really what he wants to be doing.
But he'll get his degree in that.
No. That's what he wants to do.
Okay.
But he doesn't want to do logistics. Like the big part, the reason it's blowing up is not what he wants to do. He wants to, deal with sports, and sports, predicting scores and all that kind of stuff.
Well, good. Our math in the news might have a little something to do with him today, then.
There you go.
All right. Well, before we do any of that, just a reminder, we do have phone tutors available most Tuesdays and Wednesdays between 3:30 and 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. But right now, let's take a look at today's problem of the day. This was posed on social media, and we have 5x plus 9 equals 2x plus 24. So most people that take a look at the math problem of the day and submit their answers have seen problems like this definitely between 6th grade and, say, 10th grade. Mm-hmm. Once they get through with 10th grade, they probably moved on to something else, and they see that as something very simple to do. Mm-hmm. Until they are out of school and haven't done something like that for a while, and now they're like, oh geez, how do I do that again? I forgot how to do that. So briefly, what would you think would be a good first step? We're just going to do this mentally. We're not even going to write anything out.
So for me, if I'm even just thinking about this, because I had a teacher in 6th grade that we had to do this again and again and again in GATE class.
Right, because you have to do it, and once you get it, you'll get it.
So I can always see the picture in my head. An equal sign is a balance.
Right.
So I've got 5 boxes that I don't know how much they weigh on one side, plus 9 boxes that are 1 pound each. On the other side, I have 2 boxes of some unknown weight, and 24 boxes that are 1 pound each. And from there, literally, we would start just kind of crossing out what can we take off of my balances.
Now,
So
did you
that's-
actually have, because I've been in classrooms
Yeah.
where I've used an actual balance where kids put things on each side
No,
to
we
make
had to
sure
draw
that
'em.
these things, okay.
We drew them every time. Yep. So we
So
just drew
do you
them.
prefer the X on the left or the right, or is there something else that you do to determine where you put the X?
I like to go ahead and take my, go ahead and move the two, get rid of the 2x. However people want to talk about it, that's kind of the way that most students would say.
Right, get rid of the smaller X.
Yeah, exactly, because I want to keep the positive X. I want to keep it positive.
Now, here's a lot of kids get messed up on this. If it was negative 5x, they think they still need to get rid of the 2x because 2 is smaller than 5,
Sure.
even though negative 5 is less than 2.
Yeah.
But that's just one thing that kids
I'm
have
just,
to get over.
I just always look at it and again, kind of do a mental play in my head. Is that going to make me have a negative or a positive?
Right,
so-
and eventually you will get the same
Right,
answer.
yeah,
But it's
right.
easier to work with positive x's.
Right.
So let's get rid of the 2x on
Yeah,
both sides. So we
okay.
have 3x plus 9 equals 24.
And so again, I'm just retaking my 9 boxes that I know I have on the one side. I know I've got more than 9 on the other. So if I take 9 off of each side, then I have the 15 left on the one side.
So
and
we've
none
come
on the other.
to 3x is equal to 15.
Correct.
Now we need to solve for x, because a lot of students go, all right, I got 3x equals 15, and they think that's the end of it.
Right.
But we don't want 3x's.
No, we want to find out what that one box all by itself would weigh.
Right. And a lot of times people go, well, take away 3x,
But
then you would have nothing left.
Right,
You
you're
would have
talking-
0x. And I
right.
tell kids, you don't want ox when
Right,
you're left. There's no
right.
ox in math.
Right. We're just saying, okay, so we need to know how much one of those boxes would weigh. So if I have 3 boxes that weigh 15 pounds, is basically that idea, that mental picture. If 3 boxes are 15 pounds, then each of those boxes better weigh 5.
Right, to make sure they're all equal. So what do you think the answer is?
But 5. Oh, C.
You're sure?
I don't know. I can't see that.
You can't see? You can see that? All right, so here, let me go through them.
Yeah.
A, x equals 2.
No, I can see.
Okay.
D is 7, C is 5, D is 4.
All right.
Yeah, I got it.
So you're good with C?
Yes.
You willing to bet on it?
Yes. 3x is equal to 15, right?
You're sure? I'm
we
asking
just
you right
did.
now, we know this is live TV. Are you willing to bet that x is equal to 5? Hands out. All right, let's take a look at the answer. Oh, look at that. You guys like that. All right. so
Isn't that what every teacher does? Are you sure?
Right, I want
no,
kids to be,
not
we had a
anymore.
student in here, I think, John, a couple of days ago that, a little conviction behind your answer,
okay,
right? She's
no,
like, I'm sure. That's what I want right there. No, well, is it 5? Well, you tell me, is it 5 or not? You tell me, you asking me. So that was today's problem of the day, put out on social media. Hey, you know what? Speaking of sports, let's take a look at today's Math in the News. So, Math in the News, did you happen to view the Super Bowl?
I did the second half.
Okay, well, that's going to be my next question, the whole thing or not.
I was skiing the first half.
Skiing the first
Yeah.
half, and you obviously didn't hurt yourself bad enough,
I
so
did
you were able to
not.
watch the second
I know,
half,
I'm
or
so
were you
proud of
all laid
myself.
up and you had to watch the
I know,
second
I'm
half
so
that
proud
way?
of myself. You have no idea.
All right, so you may have gone down the hill,
Uh-huh.
but not always as gracefully as you may have wanted to.
This time, actually, I did better. I'm learning this year, so yeah, it was good.
Well, you were on a 2-degree, right? So,
Green slopes, they're
yeah,
great.
there you go.
Yeah.
Whatever. So, anyway, the Super Bowl was a big hit again this year, and a lot of students know that it is Super Bowl when they see the Roman numerals, but it is amazing how many kids don't understand what the Roman numerals are.
Sure.
So let's take a look at the Roman numerals. And this was something that when I was growing up, and I'm sure you grew up on the West Coast?
Yes.
Okay. But I know back east, I mean, Roman numerals was a big thing, and I
Right.
assume it was everywhere.
Of course, can I point out just really quickly that you said ought is, what did you say? What did you say earlier about ought meaning like 0? There's no 0 there.
No 0 where?
There's no 0 there. Like it just starts with 1.
Correct.
I'm just pointing that out.
The Romans didn't like the number 0.
I know they didn't. That's
0
why
is a hero, though.
That's why I'm pointing it
You
out.
need 0.
You do.
Have you ever heard of Benford's Law?
No.
Oh, this is awesome.
Okay.
Benford's Law.
I'm scared.
Don't be scared. This is a beautiful
Okay.
thing. I tried explaining it to somebody last night. They
Okay.
didn't want to hear any part
Okay,
of it.
I'm
all right?
ready. I'm ready.
So anyway, Benford's Law. If you take random numbers,
Yep.
okay, you just look at anything
Okay.
throughout the day,
Okay.
all right, and you disregard all of the other digits after the first one,
Okay.
30% of those numbers that you've looked at will begin with the number 1.
I believe that.
And then it will go steadily down all the way to 9, which will occur 5% of the time. The number 1 will occur 30% of the time. If you randomly look through things, like you're looking at a book and you open it up to a page or whatever, or you're looking at prices of something, or you're looking at, it could be anything, addresses, anything at all.
Sure.
And they have done studies for years on this, and it's Benford's Law, and they do it with anything. Beats in a song.
Okay.
It doesn't matter what it is, but I was surprised to find this out, that it is a pretty normal curve that goes from 1 to 9, and it is always 30% for the number 1, and it goes down to 5% for the number 9.
I think that's logical.
Right, and when you take a look at prices, most things start with a 1 because
Right.
of the left-handed bias
Right.
with digits.
Yeah.
They want to start with a 1,
Sure.
even though it's 1999, instead of saying it's 2000, it's
Right.
1999.
Exactly.
So anyway, let's move on
Okay.
to the Roman numerals.
Back to what we were talking about.
All right.
Okay.
So Roman numerals is something that you grow up with, and you just kind of have to know these letters and what they represent. So we had Super Bowl 57 just now. But this, last year in all of 2022, the 100 most viewed programs in the United States, 82 of them were football games.
Fascinating.
So the number 1 was the Super Bowl, right? All last year. This, some random show, you can take a guess whatever it might have been, but it was a pretty popular show. But out of all 100 of the top programs, only 18 were not NFL football games.
Fascinating.
And this is, like college football might even be in there and things like that, because that's a pretty heavily viewed program also. But some of the numbers behind that. Here are the prices for 30-second Super Bowl commercials throughout the years since 2002. This year it was $7 million for the 30-second commercial, but you project talent, production costs, things like that.
Sure.
So the person might go, all right, I'm going to give you $7 million to show my commercial for my company, but it costs them more than $7 million
Yeah.
to make the commercial.
Right.
So $7 million just affords you that 30-second time
Sure.
slot. You're going to be putting millions of dollars into making the
Right.
commercial for that.
Depending
so
on
they're
who you
thinking
hire to.
it's
star in
probably
it, yeah.
upwards towards of $10 million
Yeah,
to
right.
make that. So a little bit of the numbers right there. Oh,
Little
indeed,
bit.
you're going to have that thing ringing quite a few times. And here was where we said, they probably went up to $7 million, and then people like Will Ferrell, that's where you're going to get this thing going up towards $10 million and stuff like that. And that is today's Math in the News. News behind the numbers of the Super Bowl.
Philosophically, I wonder though if, because you're saying the most watched. So, now that we have so many options, when you have something like that.
You're going to have a lot of things scattered
yes.
over bigger
Yeah, so I
options.
wonder if you went back to like the 80s.
I think you'd have to go back to the
90s.
70s. Then
Okay.
were you going to
Maybe.
have sitcoms and things
Yeah,
like
that
that?
everybody was watching because everybody had to watch that because that was really only the other option.
Right, when you had 3 channels
Yeah.
and the public one.
Yeah. So
That was
that word most.
Were you guys fortunate enough to have 3 channels out here?
We had.
out
we
west,
had,
in the
we
early
had,
days?
I want to say we almost had 4. Maybe.
Well, I think with the public one, that's 4, right? Yeah. PBS is a good thing.
It's a good thing.
Get to work. Over to the board, young
Oh,
lady. Here we
goodness.
go.
All right. Make it easy.
All right. You know what? You can select the number 1 to 10 or 1 to 9.
That's not going to be easy. Okay. Why don't we just? You want to start at the beginning?
All right. The number 1,
Okay.
part of Benford's Law right there, right? Okay,
Right?
here we go.
Exactly.
36 gallons of water are poured into an empty tank.
Okay.
3/4 of the tank is now filled. How many gallons does the tank hold?
All right. So you want me to do this algebraically, or you want me to break it down?
I want you to do it 2 different ways.
Okay. So let's just break it down first. We'll just do that first. So so I'm going to have my tank, and I'm going to say I have it in fourths. So I know I have 3/4 of it are full, and that is 36 gallons. So this is kind of our logic way of doing it, I suppose. So if I've got 36 gallons in my 3 three different parts that are full, then I know I have 12 in each. 12, 12, 12, which means that my other fourth needs to also have 12. So my total then would be 48. Good with that?
48 is correct. So do you have another way to do that also?
True. So I can say my unknown quantity, or the number of gallons that my tank holds is X. That's my unknown. I know that 3/4 of my tank is 36. So I can go ahead and I can set up my equation that way.
Right, and I know a lot of students that are going through pre-algebra and stuff like that will see that, and that's the first thing they'll be presented with.
Absolutely. So if we're doing this, a lot of times the question is, how do I now get to my 1x, just like we were talking about before? How do I get to just having the x? What do I do with that 3/4?
Right.
So again, I kind of like to talk to my students when I'm talking to them and say, okay, well, if I had 2x is equal to 36, what would I do? Oh, that's a 36. And they would say, oh, I just divide by 2. Okay, if I divide by 2, that gives me my x is, I would have 18. Okay, so this is kind of my general idea. So if I'm looking at this, I'm really doing no different. I'm dividing by 3/4. But we have to remember that division by a fraction is the same thing as multiplying by the reciprocal.
Right.
So we can say, all right, well, if I multiply by 4/3, if I just multiply by the reciprocal, then I can look at this right here and I say, okay, well, I know 4 times 3 is 12. 3 times 4 is 12. I have 12 over 12, which simplifies down to 1. So that's why we get to 1x. It's not that this magically disappears. We're actually doing an operation there that leads us down to 1x, but I don't need the 1 because I'm just looking at the x, and it's implied that there's a 1 there. So I've got this, and now I can look at my other side. And of course, if I go ahead and say, all right, this is the same thing as 36 over 1 times 4 over 3, I can kind of do a little bit of a simplification prior to doing my multiplication.
And that would probably be the best thing.
Right. So if I do that, I know that my magically
It's amazing when you get very close to the board that it will do strange things to you.
I can't, this board. Okay, so 36 divided by 3, I know that that is 12. So now I have my 12 times 4, which will get me back to 48. And either way, I get to that same answer, that same conclusion.
And the beautiful thing is that there's at least 2 ways that we've just illustrated how to solve that type of problem.
Right.
And there are students probably viewing this going, you know what, I did it a completely different way and I got 48.
Right.
That's the beautiful thing about math.
Absolutely. Well, and that idea that we don't have to know the algebra. We don't have to know this. We can just kind of logically
just
play around
reason
with it.
through it.
Absolutely.
All right. Well, nicely done. Just a reminder, we do have phone tutors available until 5:30 this afternoon. We have a special guest from the Bakersfield Symphony Orchestra coming in. Say that real quick. I did. Anyway, we will be back with more right after this.
All right. Welcome to Language of Mathematics. My name is Mickey, and today we'll be exploring volume. So you might be looking at the board here, and we have 2 normal types of volume. Everyday use, you might see a dial or some sort of volume adjustment. And on the right side here, we have more of a mathematical volume. So today we're going to be exploring what's the difference. Let's take a look. So the volume, like on your phone here example, if you want to make it louder, the definition is the quantity or power of sound, degree or loudness. So basically how loud a sound is or what it's doing to allow you to hear something. So by adjusting the volume, you can make that degree of loudness increase, meaning you hear more of it, or decrease where it's harder to hear and you're hearing less of that sound. An example could be I increased the volume on my phone so that I could hear the music clearly. Now, it doesn't have anything to do with math, so it's not helping us today. Let's explore another definition and see if that will help us a little more. So the mathematical volume is the amount of space that a substance or object occupies or that is enclosed within a container. So if you think about a box or a treasure chest, everything you can fit inside of it is the volume of that container. One sentence example says the student used multiplication to calculate the volume of the box he was using. So let's see, what does that look like? Why do we use volume? And I'm not talking about the volume on your phone. We're going to stick with the mathematical volume for here. So to find the space inside of objects, like we said, if you have a treasure chest and your goal is to go and raid all the ships on the sea, well, you can only fit so much treasure in your treasure chest, and using volume will help you determine how much space you have. We can discover how much space we need also. If you decide, hey, I rated 12 ships on the sea today and I need 400 cubic feet of space, you need to be able to determine, is your object or container large enough to contain all of that? And finally, we can determine if objects can fit inside of something else. So let's go forward. So how do we calculate volume? Volume is a fairly straightforward example. And for every three-dimensional object, volume has a very standard formula. It is going to be length times width times height. Using these three standard measurements, we can calculate the volume of any prism, any three-dimensional shape for the most part. So here we see we have 5 centimeters, 2 centimeters, and 3 centimeters. The nice thing about multiplication is it doesn't matter what order we put them in. So we could determine anything to be the length, width, or height. So for example, the length this time will be 5 centimeters. So we cross it out, we've already used it. Maybe our width, we want to choose 3 centimeters, okay. And finally for height, we have 2 centimeters left. So again, calculating volume, we multiply all three of these measurements together. So 5 times 3 gives us 15, and 15 times 2 gives us 30. So we have 30. Now sometimes you might be wondering, Mickey, why sometimes do we put these numbers next to the centimeter? Because I know my measurement is in centimeters, but the question is, why do I have to put all these crazy numbers up there? And students wonder, why do I have to put the 3 up here as the variable? Here's the reason. When you get into algebra and you start working with more of these terms and different measurements, when you are calculating volume, we look and notice, well, hey, I have 3 measurements that are all centimeters. Do you see a correlation there? We use centimeters to the 3rd power because you multiplied 3 centimeters together to get volume. So if no one ever told you why, your teacher tells you it's because, it really is because we have to match our power with how many times we multiplied a measurement together. So that is today's language of mathematics, and hopefully you learned a little something about volume. It's not just on your phone, but it's also the space in the world.
Always nice to learn a little bit more about language and how
Yes.
words and wordplay, and especially the English language.
Yes, and I actually really like that idea of centimeters, 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 because sometimes if you were to measure them differently, if you had centimeters and then inches, and you multiplied, you'd get, 3 centimeters times 5 inches is not 15 centimeter
Right,
inches.
you're gonna have to convert things.
Yeah, it helps you remember that you need to get them all the same.
You like money?
Sure.
All right, over to the board. I got a money problem for you. Tom went to a store and spent 1/3 of his money.
Okay.
He then went to another store and he spent 1/3 of what remained.
Okay.
He then had $12 left. What did he have to start with?
Okay, so here's our question. Okay, so we don't know. He spends 1/3 of it. He spends 1/3 of what's left, and then he ends up with $12. So we're going to work backwards, yeah? All right, so my initial thought on this is there's a few ways I could go through this, but I'm actually just going to go ahead and take more of my logical approach. So kind of like we did on the last one, we can do it 2 ways. My idea here is that if they spent magic,
Let's try your back arrow.
I magically.
There you
Okay,
go.
there we go. I don't know what happens. I swear it's just
All
me.
sorts of stuff's happening
It's just
now.
me. Okay. All right. So I'll magically stay away from the board. I know that if they spent 1/3 of it, then what they have left is 2/3. So my 12 is actually 2/3 of what they had here. Okay, so that's kind of what I kind of like to think about a little bit, that what is my 2/3? So again, I can take kind of that same idea that I did before. If I have my money and I have it in thirds, and 2 of those thirds adds up to 12, then I know I have $6 and $6. So that last one was 6. So he must have had $18 before he spent 1/3 of it, and then was left with the 12. So that's kind of the way I'm going to start with there. So then I say, okay, so fine. So we had $18 here. So if I am then saying, all right, so 2/3 is what was left after 1/3 of it was spent, then what is this again? I'm going to say, okay, so I have, again, thirds, and I had 2 of them left that gave me the 18. So I know I have 9 and 9. So my last third must have been another 9. So that tells me then that I started with 27. Now, of course, I'm not going to stop there. I am going to check it. So I am going to say, okay, so 27, a third of 27 is 9, which left me with $18. A third of that, of course, she's spending again, which is $6, which leaves me with my 12. So I can kind of, go back and look at it
There you
again,
go.
just to confirm.
Nicely done.
$27.
Well, as promised, we will have our guest in very shortly, but first, we already took a look at the language of mathematics. Now take a look at the tools of mathematics.
Good afternoon. My name is Rosalio Salcido. I'm the instructor for the Southwest Carpenters Training Fund. I'd like to introduce you to 2 different tools that we have here. As you see, we have a speed square combination here, and we also have a framing square that we use on the field. I asked my apprentices which one is easier for them to handle, and they all vote for the speed square because it's handy, and believe me, it's a lot safer. As you see here on the back, we have a 90-degree. The simple cut, straight cut. Now, if I want to go ahead and make a pivot point, and you follow where you see the degree point at the very bottom, and I'll stop at 45 degrees. I'll go ahead and scribe, and there it is, 45 degrees. I'll go back to this number here, which is a 4 and 12, which is a common California pitch on a roof. So how do I achieve that? Well, the same portion, you go ahead and put the pivot point. You got another set of numbers up here, which is the commons. These are your rafters for the roofs. So now you set it again, you pivot point up at the top, and you're going to chase the number back up here on the corner. Always working off on the top. So now you're going to go and scribe. Now you got yourself a pitch, a 4 and 12 slope. Okay. So now we look at this one here. This is a 12 and 12. It's getting a little steeper. Maybe you're out there in New York where it snows a lot. You want that roof to come down. Now, we set it back over here at 45 degrees, and that's a 12 and 12 pitch. 12 inches up, 12 inches on the horizontal. Now, we come back out here and we set it again. This one's a little trickier because it is a 22.5, which in combination of 22.5 plus 22.5 is going to give you 45 degrees, okay? So that's where we try to tell the apprentices the mathematics of it. It's simple, it's dynamic, but it's a useful tool on the field, and hopefully every apprentice gets a chance to use this.
There we go, the tools of mathematics. They are all around us every single day. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Right now in studio, fortunate enough to have a member of the Bakersfield Symphony Orchestra with us. Jared, how are you today?
I'm doing great.
What is your role with the symphony?
I am the principal trombone player, so I play the really high trombone parts in the Bakersfield Symphony Orchestra.
So is that because you're the principal, or that's the part you play and you also happen to be the principal part?
Second one, there you go. Yeah. Okay. Yep, I auditioned for it back in 2018, and I got the spot. So I'm really grateful to be playing in the symphony.
And so how often do you practice? I mean, to be part of the symphony?
We have concerts about once a month. We have a total of 8 concerts throughout the year, including the family concerts and the holiday concerts. And so we have about 4 rehearsals over the course of that month. And the concerts are always that first weekend of the month.
All right, great. Well, thank you for coming in today. We have a rather young student for Do the Math on today, but Jolene was nice enough to come in today and share a little bit of time with us. So what will you be talking with Jolene about today?
Today we're going to be learning about partials and the harmonic series and how a brass player can play many different notes. And we're going to be doing some counting and looking at the relationship and the intervals between these notes. First, I want to play a little something for everybody, for everyone watching, and for you, Jolene. This is by a very famous composer, by John Williams. Let's see if if Jolene or our viewers can guess what this is. You recognize what that was? You ever heard it before?
No, but I think it's the Smarty Ants one.
So that was the Imperial March from Star Wars, Empire Strikes Back, also known as Darth Vader's theme. So I don't know if you noticed, Jolene, but I played a lot of notes in that. Did you hear how high I played and like how low I played sometimes? Did you hear the difference in the pitch?
Yeah, because it's familiar with the Smarty Ants one because the high notes and the big notes.
Yeah, exactly. So in order for me to do that as a trombone player, there's a certain thing that I have to really know and understand as a brass player, and that is what's called the harmonic series, also known as intervals or partials. And so what do you notice about the trombone that's unique? What is this right here? Do you know what this is?
A trombone? It's for you to blow the thing so it can make the music.
Yeah, so this is also called, it's a slide, right? So some instruments have certain keys, or string players have certain strings they have to cross to get high, but on trombone, we have to use our lips and our air and in order to change the pitch. And so we're able to do that because of partials and the harmonic series. So I want to demonstrate just a little bit over here on the board. Just so you know, there's 7 positions on trombone. 1, 2, 3, 4, 5, 6, 7 way out here. Look how big that is. It's like almost twice the size as you, right? So it's pretty big, right? That's really far out. So in each of these positions, I can play a certain amount of notes. So. So on and so forth. I can keep going down all the way down to the 7th position on the trombone. So I want to go over here to the board, and we're going to do some counting and we're going to kind of examine how these notes all relate to each other. So the very first note that a brass player can play, we call this the first note or the fundamental note, is way, way down here. Check this out. Look how low that is. So notes up here be really high, notes down here are really low, right? You see how low that is? That is a low B flat, okay? Well, the very next note that I could play, and I was demonstrating for you on each position, is the note right here on this line. So I want us to count from this lowest note up to this note together, and you're going to see how far away that is, okay? Let's count. And so we're going to count, including the note, the line, and the space in between. I'll help you. It's okay. So let's count together. 1, 2, 3, 4, 5, 6, 7, 8. So how far away is that?
8.
8. So that's 8 different notes away. But in music, we call that an octave. That is an octave. 8 notes away is an octave, okay?
Okay.
The next note that we have from this one right here is an F. It's on the F line here. Let's see how far away this note is from the B flat. Okay, let's count together. Again, we're going to count every line and space in between. So here we go. 1, 2, 3,
4, 5.
5. Good. So this note right here is 5 notes away, or an interval of a fifth. In music, we call that a perfect
Sound.
fifth. Those are some of the most pure and wholesome intervals of notes. Okay, and the interval is the space between 2 different notes. All right, you're doing really good, Julian. Let's do the next one. So after the F, we have a note right here.
Which is
This is a B flat. Okay, let's count those lines and spaces starting on the F. Here we go. 1, 2, 3,
4.
So how far away is this B flat
4.
from this F? Good. 4. In music, we call that a perfect four, a perfect fourth. So I'll put a P4 there. Okay, perfect fourth. All right. All right, and then the next note we can play is actually right here. Okay. So let's count how far away this note. This is a D. This is a B flat. This is a concert D. Let's see. Let's count how far away this is, including this note right here. Okay. 1, 2,
3.
3. This one is
The perfect 3.
well, almost perfect 3. We call it a major. You're on the right track. That's really good. It's actually called, I'll write it down here, it is a major third. Okay, a major third. And it sounds happy, that interval, right? So far we have a low B flat, octave, we said 8 higher, 8 notes higher, right? And then B flat to F, 5 notes higher. Right, and then we have an F to another B flat, a fourth. Right, you want to hear that, and Here Comes the Bride, maybe. And then next one we have B flat to D, which we just learned was a major third. Okay, so now the next one, this one's a little tricky because it's the same, it's going to be a similar number, but it's actually going to be called something a little bit different. So let's count how far away this one is. Now, we're going into a different clef here. You can ignore that for now, but the distance is exactly the same, okay? So we have 1, 2,
3.
Good. 3. So this is actually, we said it's 3 notes away. That's actually a minor third, okay? So it's actually sadder sounding. In music, we have major, which is happy, and minor, which is sad. And this interval, again, the distance between 2 notes, is actually sadder sounding, a D to an F. Versus a major third. And then, we're almost there through them all. Look right here. So from the F, the next note is actually going to be right here. And I'll put a flat sign because it's actually an A flat. Okay? So let's count how far away this is. 1,
2, 3.
Good, good, good. So this one's also a minor third. Okay, I'll put M3. Marker's a little thick here, but minor third. And this note is really out of tune, so we don't really play it a whole lot on the trombone in that position. We play it elsewhere, okay? And then the next one, look at this, is going to be right here. Let's count how far away this note is from this note, the interval here. 1,
2.
Good. So this is actually a major second. Major 2 or major second, right? So these notes can keep going higher and higher. The next note would be right here, and the next note would be right here. What do you notice happening to these numbers? We had an 8 down here. We had a 5, a distance of a fifth right here, a fourth, a third, an even smaller third, another third, and then a second. What's happening to the notes as we get higher up? Are they getting larger in distance, or are they getting smaller?
It's getting larger and then smaller, then larger and smaller.
Right, so actually the trajectory of this is that the notes, as we go higher, the notes are getting smaller. The intervals of the notes are closer together. And this is what we call, I'm going to put it up here in bold here. This is what we call the harmonic series, based off of intervals. And each one of these notes is a partial. We call that a partial of how a brass player can play all these different notes in one position. Here's the cool thing. The range, as far as how high we can go, the sky is the limit. Other instruments, they're limited by keys or the strings they have on their instrument, but on brass playing, the sky is the limit because of how close each and every single note is getting. So as I play higher, my lips and my lips and the air that I blow through, everything is much closer together. So these are really close notes. So this is the harmonic series, all based off of the distance between different notes. Isn't that cool?
All right, thanks for that, Jared. Jared, I've got a question for you. So as you're playing these higher notes, do you employ diaphragmatic breathing where you're trying to keep your breath so that you can keep on going without stopping? Because it seems like after a while, higher and higher, the more pressure you're having to put in, the more air to deliver through, it's just going to take a little more effort.
Yeah, and actually it takes a lot of effort. I tell my students all the time that it's like doing a pull-up. If you've ever done a pull-up when you grab the bar and you pull your whole body up and try and get your head over the bar, that condensing of your diaphragm is what really helps you get these upper notes because they're so close together and they're so high. As we get higher, the numbers get smaller apart. So it takes a lot of pressure and a lot of squeezing of the diaphragm to get those higher notes to pop out, for sure.
Well, excellent. A nice illustration of the notes and the counting and starting with the octave and going all the way up like that. And thanks also to Jolene for helping you out a little bit right there. When is the next concert?
The next concert is on Saturday, March 4th. We're doing Verdi's Requiem with master chorale and choirs from Cal State Bakersfield and Bakersfield College. So it'll be a really good concert.
And you guys have worked with them before, because I know that especially during the holiday one, you have them there, and then other times throughout the year as well.
Exactly. Yeah, we had them back for some music from Home Alone and things like that in the holiday concert back in December. And it's just so fun because you have voice, you have strings, percussion, brass, reeds. It's a really cool time, and it's a really awesome experience to hear music with all instruments together, so you won't want to miss it.
All right, well, if you'd like to find out more about that, all you have to do is hit the website down at the bottom of the screen. Jared, thank you for coming in this afternoon. We'll be back with more right after this.
Thank you.
Am I ever going to be judged for participation?
I'm so glad you asked that question. Getting scored on your participation in class might not make sense to you today, but I can tell you that in the future, things that you do will always be a part of a team, especially at NASA. Active participation and being able to communicate your ideas is incredibly important for being successful in the workplace. At NASA, we rely on the participation of every member of our workforce to make our mission successful. The creativity and innovation of this agency is fueled by individuals who contribute their unique perspectives and aren't afraid to speak up. So yes, actively participating is one of those skills you gain through classroom participation that will truly benefit you for years to come.
When am I ever going to need to use these history lessons?
At NASA, history is really important to us. For example, we're applying lessons learned from the past Apollo moon missions to help us prepare for the Artemis missions going back to the moon and beyond. In my job, I rely on the lessons learned from past robotic missions to help us fix satellites and collect samples in space. History isn't just about memorizing dates and names, it's about learning from the past and using that knowledge to make the best decisions for the future.
When am I ever going to need to use physics, chemistry, math?
You can use chemistry to bake a cake or to make new medicines that can help people. You can use physics to ride a skateboard or to build a rocket to explore the planets. You can use math to figure out if you can afford to buy that really cool car or to understand what's happening inside a black hole. Here at NASA, we're using math, physics, and chemistry on DART, the Double Asteroid Redirection Test Mission. On September 26th, the DART spacecraft will deliberately crash into the asteroid Dimorphos at a speed of 15,000 miles an hour, changing the asteroid's motion in space. We're doing this to learn how to deflect asteroids, prevent a collision, and keep our planet safe.
When am I ever going to need to study as an adult?
That's a really good question. And I feel like I've been studying my whole life. So I studied throughout school, and then when I got to NASA, I kept studying so I could learn more. I'll give you an example. When I was going to school, I studied engineering. And then when I got to graduate school, I changed over to science. And I became an expert in the skeletal system and got my PhD on what happens to bones when we go out into space. Then I came to NASA and I was responsible for implementing a scientific strategy for a lot more human research than I had learned in school. So I had to keep learning. So I already knew about the bones, but then I needed to learn about what happens to the cardiovascular system in our hearts when we go into space. What happens to our muscles when we go into space and we don't use them as much anymore because we don't have the effects of gravity, and the entire human body in space. So I feel like I'm just always constantly learning, and I love it.
When am I ever going to need to present anything?
So I'm so glad you asked that question, because presentation skills are honestly crucial life skills. And you might not know it, but you're actually exercising and training this muscle almost all the time. So let me give you the perfect scenario. Engineers and astrophysicists at NASA recently released the highly anticipated James Webb Space Telescope first images. And in these amazing images, you can see hundreds and thousands of stars and galaxies all around. But we had to present that information to the general public. And even now, I can tell you cool facts about how Stephan's quintet has 5 galaxies almost forming this galactic dance with each other, and how we know that there's an active black hole in at least one of them. You see, presentation skills allow you to articulate your thoughts and ideas to your audience and help stir them to either thought, action, and in some cases, even both. Great question.
When am I ever going to need to work in groups?
Well, let me tell you, Clayton, at NASA, we work in groups all the time. In fact, no one has ever gone to space by themselves. I know what you're thinking. Megan, those first space flyers were in a capsule with just one seat. But even then, it took a team to get them there and to get them home safely. When we're tackling the big, important problems, like designing and operating new spacecraft, we need a team of people willing to bring their best ideas, their questions, and their solutions to make it all work. Sometimes you need to step up and be the leader. Sometimes you need to be a strong follower, but always you need to be respectful of what each person brings to the team and support each other to reach mission success. Together, we will go far.
Well, that was fascinating to have Jared from the Symphony in studio with us and talking a little bit about the trombone. And as soon as I heard that music, I know that you may not have seen the Star Wars movies. What about you?
Oh, absolutely. Actually, John Williams is one of my Pandora stations that I have on kind of all the time, especially in my classroom.
Okay.
So, yeah.
Star Wars, John, you grew up, did you see the Star Wars movies and stuff like that?
Yes, I did.
You did. I did not. I think I've seen
So weird.
parts.
So
you see
weird.
now, sister, let's not get into it.
Didn't know
Okay?
anything about it. Didn't know what to expect. First one I went to.
I remember seeing part of it, but I didn't go to like the theater when they first came out and stuff like that. I do remember Jaws, that was a big thing.
Okay.
But the Star Wars things I missed out on kind of. But when I hear that music, that reminds me of announcing baseball games, because when the mound visit happens and the opposing manager comes out, that's what they play sometimes. So that's the first thing that popped into my mind right there. Anyway, in studio we have Jolene. How are you today?
Good.
Where do you go to school?
Voorhees.
Voorhees Elementary, huh?
Uh-huh.
What grade you in?
Second.
How's that going?
Good.
Pretty good?
Mhm.
Really good?
Yeah.
Is it pretty easy?
Yeah.
What's so easy about it? Like, what do you like doing about it?
Reading in English, reading in Spanish, doing math.
So you like all those things?
Uh-huh.
What kind of math things do you do in second grade?
We do 11 plus like any number, or like 10, or like 9s.
Do you have a favorite number?
10.
Why 10?
Because it's easier, because like 7 plus 10 equals 17.
It's an easy number to add and subtract with, right? It's a nice even number, so 10's your lucky number right now?
Mm-hmm.
All right, well hopefully Oh, there you go. You got a little congratulatory ding dong right there for the number 10. I've got a question for you. Have you ever seen Sesame Street? Do you ever know that show? I know that I don't even know if they have it anymore.
No.
They do? All right, so Sesame Street is still out there. And anyway, they have this guy on there called the Count. What do you think he does?
I don't know.
Well, if he's called the Count, what do you think he does? If I called you the Count, what do you think I would want you to do?
I think you want me to go get a shovel and get the snow.
Well, okay. Well, that's one thing you can do. Count how many feet of shovel you can snow. Anyway, good answer. So I know that you understand. You know something about the nines, right? The number 9?
Yeah.
Can you explain that and show us what you mean with the number 9?
So 9.
So if I want 9 plus something, what would you do?
I'll use my fingers, or if I have a paper, I can just use sticks.
Okay, but we're going to use your fingers because you don't have the paper with you right now. And there's a lot of times on Do the Math where we've spoken about if you need to use your fingers to do math problems, you use your fingers to do math problems.
It's a tool.
Right. So it says one of the many tools. So show us how you do 9 plus 8.
9, 11, 12, 13, 14, 15, 16, 17. It's 17.
Yeah, it is 17, right? You caught yourself because I think you went 9, 11, right? You forgot your favorite number. What's your favorite number again?
10.
Yeah, 10. All right. So you also do some addition in 2nd grade at Voorhees, correct?
Yeah.
All right. And you kind of move the numbers apart, correct?
Yeah.
All right. Why don't you head over to the board, and you and Cece are going to talk a little bit about this and show us how you do it.
Oh, you're going to come over here to this one.
Yeah, I know you worked over there with Jared, but this is a better board now.
Yeah. So I'll do
right.
it since it's too high. It's a little
So
high.
here.
Okay.
Let's
oh,
go
you want to
ahead
do this
and,
and have her do it?
Well, we'll just get her up here.
Okay,
So,
all right,
yeah,
all right.
Put it where you like there, sister.
Okay.
There you go.
Okay.
All right. So, what number would you like to start with?
8 plus 9.
Well, we already did that. I want to move on.
10.
What other number would you like?
10, 9. 10 and 9.
10 and 9?
Yeah.
Let's have 10 and 19. How's that sound?
Good.
Can we add those together?
Yeah.
Do you want to show me how to do it? And how in the world did you know that?
Because there's a 0 up here, and
Okay.
then you put the 0 with the 9,
Okay.
and then it equals to 9,
Okay.
and then you have 1, and it equals to like 2. So I added 2 here, but it had a higher number, and it had another 1. I put the 1 up here.
Oh, well then wait. Yeah, okay, so you know how to do that. So we're going to do that next. You ready? You want to try another one? Here, move your box over and we'll do that again. Okay, here. Can I do this? I'm just going to do
I was going to say, let's do it where now she has to move on, where she had, in the 10s, she has something that's going to go over 10. when she
Okay,
had-
so let's do 95 and 19. How about that?
Okay. Plus, do I put
Oh
a
yeah, I'm
plus-
sorry, yes, absolutely. Please add the addition sign. Okay, so now show me.
9.
Okay, pause real quickly. Okay, we're going to do that again. So 9.
9, 8, 9, 10, 11, 12, 13, 14.
So so do you erase? We're going to do this.
Oh.
It's really cool. We go a circle around and boop, right in the middle.
I get to keep the 1 up there for
You do, because that's a 14. Yes, absolutely. So now why did a 1 go up here? Do you know why?
Because we can't add the 1 right here, or you go to one of the 100 stuff.
Okay, because we know that a 14 is 1 tens and 4 ones, right? So we're going to go ahead
and this is going to equal a 10,
Okay.
and then I add 1 more, and it equals 11, so it's going to equal 14.
Oh. Wait. You're
maybe
right.
she's not done yet.
Okay,
She knows
all right.
she
I'm going
put
to
the
back
1
off.
there,
I'm going to
so
back off.
let's
Go ahead
see
and
what the
finish
next
it.
step is.
Oh yeah, you can't touch the board. It's a problem I have too.
No.
That's right. Tell me why.
Because there's 11 right. There's 11 when you put the 11 right here, and then it equals to 14 right here. And let's do like 5 plus 9 equals 14, and I'm gonna put the 1 up here,
Yeah.
and then put a square.
Okay.
And the 4 is gonna go here.
Okay.
And 11, this is gonna equal 9, but it's actually gonna equal 11 because there's a 1 up here.
Agreed. So the 9, 10, and then that other one,
11.
Nice. 114. I like it. Very nice.
So Jolene, how are you with subtracting numbers?
I don't know yet.
You don't know yet? Well, let's find out. Let's clear the board and we'll work on some subtraction.
Okay, so we're gonna do like a big circle. Do as big. Sorry, I'm a mess today. I know it's really bad. Look, see, it's not even working for me. Okay, here I'm gonna do a big circle and a dot, and we'll make it go away. Okay, and then a big. There we go. All right, and we're done. Okay.
All right,
I'll leave
so
it to
let's
you.
go
Go ahead.
56
56
minus,
minus.
and you come up with a number. Well, you like those numbers in the teens, huh? All right,
Okay,
56
okay.
minus 18.
Okay, show us what to do.
8, take away 6. 1, 2, 3, 4, 5, 6 equals 2.
Okay, so I'm gonna pause for just a second because you're doing 6 minus 8,
So
or
let's-
you're
here,
doing
let's-
8 minus 6. I need the 6 minus the 8.
Before we do that, let's erase the 8. So erase the 8, Jolene. And I
do-
want you to put a 3 down there.
Yeah, and
so
then
it'll
we'll
be
do-
13.
We'll do this first. Okay, now go ahead and do that one.
6, 1, 2, 3. We could have just do adding.
Well, we're doing subtract. We're gonna do subtraction for right now. Okay, so what did you do? Explain what you did really quickly.
Because I made a mistake and I had it at 8 here. And how would you take a 6 or take away 8? So I erased it. And I put a 3 and it equals to 3. And then we put a 5. We put a 5 up here and it equals. And you take away 1 and it equals 4. So it equals to 400. 43.
Very nice. Very
That was
nice.
awesome how
Yeah.
she goes, how can I take 8 away if I only have 6?
Exactly,
So
exactly.
The reasoning is there.
Yes, absolutely.
Yeah, because you had 8. 8 take away 6. 6 take away 8. You equaled like to adding. You put adding.
Okay, so you're going to do something else with Cece. now.
Okay, so now we're going to do this problem again,
And
and
you
I'm
guys
going to
have
show you.
1 minute to do this.
Okay, now I'm going to show you really fast. Now you're right. I cannot take 8. Well, I can, but for right now, 6 minus 8 is going to give us a number we're not quite sure of, right? So I am going to borrow from this 50. So this is a 50, right?
Yeah.
So I'm going to turn it into a 40 and make that a 16. Do you know what 16 minus 8 is?
16. 16. Hang on. 16. Hang on. 1, 2,
Where you can
3,
go up
4,
from 8.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Take away 8. 1, 2, 3, 4, 5, 6, 7, 8. So how much do I have now? 1, 2, 3, 4, 5, 6, 7, 8.
That is beautiful. That is beautiful. Because we borrowed a 10 from that 5 and did that, now we've got the 4 minus the 1 and high five.
You are all through. You did that just like the count would do it.
That was fabulous.
Come on over
Wait,
here,
we need a
Josie.
ding, ding, ding. There you
Jolene.
go. There we go. Come on over, and we'll talk to Mike again.
Okay.
So we have a couple of seconds. So, did you learn a little something today about the trombone and about math?
Yes.
Yes, you did. Did you have fun today?
Yes.
You were awesome, and you did
You were
work
great.
just like the count. Give it to me right there, sister.
And you know,
Nicely done.
what the count does? 1, 2, 3.
And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.